Hey, so this is going to be a quick tutorial slash walkthrough on how to get pre-rendered backgrounds to work in UE4 and UE5 using Blender. So I'm just going to walk you real quick through my setup here. So I just have a standard scene that I got from Blender. So these are just some static meshes that serve as invisible collision geometry that the player collides with. Now you're not going to see those in the game. But I just have some temporary materials on them just so I can see them here in the editor. Then I just have a bunch of camera angles or a bunch of cameras that I got from Blender. I'll show you how that works, how you sync the cameras and get them from Blender a bit later. But yeah, and then you have just these boxes here, these overlap boxes. So the player enters the box, and the game camera will change to this camera here that's connected to the box. So if I start the game, this is what I get. So these are the pre-rendered images that I got from Blender, and you can see them right here. So as you can see, the player can walk behind objects and he's correctly obscured by them, and change camera angles, standard tank control stuff. Everything works fine. And yeah, so I'm just gonna walk you real quick here. This is not a detailed tutorial. If you want an in-depth step-by-step, let me know. I'll see if I have time to do it. So let me pull up my notes here. And this, I basically wrote down everything you need to do to get it to work. So you could just stop the video, read this, implement it, and you're gonna be good to go. So let's start with Blender here. So in Blender, you're gonna be creating your scene. You're gonna be creating your geometry, the cameras, the images, get everything set up. And then once you're ready to pre-render, make sure you set your output settings to be OpenEXR 16-bit float. And the reason we're using OpenEXR is because it lets you store much larger values than 256 per channel. And what we're gonna do now, there's two ways you could do this. You could generate a separate image, your pre-rendered image as a PNG, and then generate a separate depth map along with it. Or if you go this route with the OpenEXR, you could just store the depth in the alpha channel. So you don't need a separate depth map, which is really good if you want a fast workflow. And one of the reasons pre-rendered backgrounds kind of suck is because they slow down your iteration time. And so the more step you could get, you could cut down from the process, the better it's going to be. So having one image instead of two is going to be great. And as you can see here, I don't have any depth images. It's just the pre-rendered backgrounds, and I'll show you how that works. The next thing is setting up your composite, and make sure you do your conversion there. I'll show you how that works, and then you just render the images and bring them over to Unreal. So I'm just going to go over to Blender here. So this is the exact same scene that you've seen in Unreal. Now you could export these as like individual meshes, or you could just combine everything and bring it as a single mesh. It doesn't matter. Now I'll go over how I sync the camera settings and stuff later. It's just this step really depends on your setup. Like you could be not using Blender, you could be using 3D Max or whatever, so this might change. But what I want you to take from here is that, this is your setup, this is your collision, these are your cameras, and then if you go to, let me just get this out of the way here. If you go to your output settings, just make sure, so this thing right here. Now, disclaimer, I'm not a Blender expert. I'm not a Blender guy at all. I'm a programmer. I'm not an artist. But you go to your output settings here, and what I like to do is just output to the project directly, so I don't have to find it. And then just make sure you have OpenEXR here as the setting. So just make sure OpenEXR, RGBA. You don't have to use full float. So full float is 32-bit per channel. I found that half is fine. So this is 16-bit per channel, and it's basically gonna cut down your size by 4 times. So if you go full, it's gonna be 4 times as big. So for what you're doing, if you're doing like a PS1 game and you don't really care, you don't have big distances, like 16-bit should be enough. If you encounter issues where you need to go further, you could choose 32-bit. So that's that, and then you go to your compositing, and that's literally all you have to do here. All you need to do is get the depth. Now the depth here, what does that mean? That means it's the distance from the camera to the pixel. So this is a distance. This is not a normalized value. This is not a 0 to 1 value. This is actually the distance in meters from the pixel to the camera. So since it's in meters, we just multiply it by 100 because we're using Unreal, and Unreal uses centimeters as opposed to meters. So 1 world unit in Blender is 1 meter, 1 world unit in Unreal is 1 centimeter, and 1 meter equals 100 centimeters. So you just multiply here, and then just pass it as the alpha value of your composite, and make sure you use this. You check this, use alpha here, and that's it. Now you just go and just go through your cameras and just if I can remember how to render things, you just render image, save as, you put it wherever you want to put it. It's going to save it as EXR. Now you don't have to change anything here. That's why we set these output settings, is because it's going to pull from these output settings. So you don't have to change anything here. You just save it and you're good to go. Now, if you're like me and you're like a workflow freak kind of a person, this is not good enough because it's going to be slow. If you have a lot of cameras and you want to update them, you want something that's really quick and easy. So I have a little tool here. In tool here, yeah. So I basically wrote a little Python script that you just press the button and it will iterate through all the cameras and render them out. It uses this path here. So actually this already did update all these images here. Yeah, so it just saves them and updates them for me, so I don't have to go through each camera. I'll show you the code for that later. Maybe I'll post it somewhere. So yeah, that's all you have to do in Blender. Okay, so back in Unreal, what I'm actually gonna do is just duplicate the scene and just strip out all these extra features that I've added, and just show you how to just set up a single pre-render from scratch. Like, just get rid of all these extra cameras. So all I have now is just a single camera, and I have my player here. So we're gonna try and get this angle to work, which is this cam 0 here. So if I run the game right now, nothing really happens. And this is because actually we have these, we hide the collision geometry here. So if I unhide it, you're gonna see this is just the third person controller. I modified it to use tank control. So what I'm gonna do is I'm just gonna make the game use this camera here. So for this is just a demo, so I'm just going to use the level blueprint here. So I'm just going to get the player controller and set view. So this just sets the game camera. to this camera here. So now if I just run the game, it's just going to use this camera here, no matter where I go. So in order to get the pre-rendered image to work, what we're going to do is we're going to create a post-process volume. So if you search for post-process, just add this thing. Doesn't matter where you put it, because we're just going to go here and search for infinite extent. So infinite extent means it just extends forever, so it doesn't matter what size it is. It's going to cover the entire world. And you're going to want to search for material, and we're going to create a new material. Just assign it here. And then just open it up. And the first thing you want to change is you want to change this to be a post-process material. So in the material domain here, let's choose post-process. Now in a post-process material, what happens is like all the rendering has been calculated, but it hasn't been outputted to the screen. And Unreal uses a deferred renderer. In a deferred renderer, there are multiple render targets that you could access, and one of the render targets is the scene depth. Now the scene depth describes how close things are to the camera. So if you search for scene texture here, you'll get this node here, and you're gonna get a drop down with like a lot of options. These are all the render targets for Unreal. So if you choose scene depth, and actually before scene depth, I'm just going to duplicate this and show you. If you type post and choose input 0, this is basically the final rendered result. So if I run the game with this, nothing happens, right? It's the same result. Now if you hook up scene depth, you're just going to get a white screen. The reason is depth is distance to the camera, and those values are going to be much bigger than 1, which is like the maximum value for the brightness of a color. So if you just take this value and divide it by let's say 3000, this is just for visualization's sake. This is just to show you what this depth actually does. Okay, this is too bright. Maybe try 4000. Yeah, so this is just for visualization's sake. So the closer something is to the camera, the darker it is, and the further away, the brighter it is. So yeah, so it's just describing distance to the camera. So we're gonna actually use this and compare it against our pre-rendered depth. And if the scene depth is less than our pre-rendered depth, we want to render the scene. Otherwise, render the pre-rendered image. So if you grab, it's going to be cam 0. Now, if I just connect this right away, you'll see that it's actually dark. And the reason for that is, remember, this has no color transformation on it, so this has no sRGB on it. So we need to convert the RGB, convert linear space to sRGB to get the correct color. Append everything back. So now if I connect this, you'll notice we get the actual pre-rendered image. But if I run the game, like I don't see the player. So we want to, like I said, we want to choose between this RGB and this based on the depth comparison. So in order to compare two values, you're going to want to use an if statement here. So if the scene depth, I'm going to plug this into A, and I'm going to plug, actually it doesn't really matter. I guess for cleanliness sake, I'm just going to plug this alpha here to the A and this to the B. So if our prerendered depth is less than B, we're gonna want to use this RGB. Otherwise, we want to use this should be like this. So compare scene depth with our prerendered depth. So if our prerendered depth is less than the scene depth, we want to use our RGB color. Otherwise, use the scene color. And there's, if you know your shader math, you could easily achieve this by a lerp. I'm just gonna press 1, hold 1 and click, and I'm gonna get these constants here. So one of them is gonna be 0 and the other is 1. And it's a bit tricky to think through this sometimes, so if A is less than B, yeah, let's do it like this. So if A is less than B, we're gonna return 0. Otherwise, we're gonna return 1. And you could plug this here. You can plug either of those to the equal, it doesn't really matter. So A less than B, use our RGB. Otherwise, the scene color, and you just connect that. Now you'll get an error here just because this is RGBA and we just want the RGB. And if you run the game now, you'll actually see the player now. And notice how there's these striations and stripes in the mix between the pre-render and the world. And this is what you want to see. That means that your depth values are actually correct. If you don't have the correct camera settings, so I just pressed F8 to disconnect, and I'm just gonna click the camera and then just change change this field of view or the aspect ratio, and then when I run it, you'll see that it's like totally wrong, and things are very wrong. And when you see this, that's usually a sign that you don't have your camera settings correct. So I'm just gonna undo a bunch of times. Oh my god, okay. That did too much. So yeah, you don't wanna see the world, so you just go and hit an in-game. And that's it. Now you have your character running around. It doesn't switch cameras. That's something separate. That's different. You're gonna have to write something for that. If you don't know how to make a static camera angle system, I could do that as well, show you how to do it. But yeah, now you'll notice that you can move around in the world, but you still actually see the pre-render background. This is because the post process is still enabled here. So if you press enable and you just disable it, you won't have that. But now the problem is, like, you run the game and there's no post-process. So what I actually do is just, I have like a camera manager, and when the camera manager initializes, it just enables the post-process volume. And you could just do that here real quick if we're using the level blueprint here. Just set enabled. True, and this is, don't do this. This is just demo stuff. Don't do this in the level blueprint. But yeah, if you run now, it works. So, yep, that's it. That's it for the material. I'm just going to show you one little thing with the material here. Notice how we're using an if statement here. You don't have to use an if statement because like this is going to be running for every pixel on the screen. An if statement might be expensive depending on how it's done in the background. Now, I don't think this actually emits an if statement in the shader. But if you don't want this, like you could easily, I'm just going to show you my actual material here that I use. So this is the same thing that we just wrote, except instead of an if statement, it's just a custom expression that just calls into the step function. Now the step function just does this. If A is less than B, return 1, otherwise return 0. And you just type custom here, and then you just like return step A, B, that's it. And then you just give it 2 inputs. And just connect your A and B and connect the output, and off you go. Okay, so I'm gonna have to end this here. This is way longer than I expected. It's just there's a lot of stuff going on in this, and it just takes way too long to properly do it step by step. So sorry if I just skipped on a few things, but I'll make a separate video how to sync the settings, the camera settings from Blender to Unreal. Well, yeah, for now I have to take my dog out. She's really mad. But yeah, yeah, I hope that was useful, and I hope you got something from it. I just wanted to get the technical side of things in Unreal figured out so you could see that it's actually very simple, very easy. This is Abby here, and we're gonna go take a shit together. Well, not me, but, well, hopefully not me outside, but alright, see ya.